Well, I've been traveling around the world looking at some of the more extraordinary ants, and I'm often asked about the parallels between ants and humans. Are there any? Well, it turns out there are. A reason that is so is that ants, like humans, can have societies in the millions. That's far larger even than a bumblebee colony. And many of the attributes of an ant colony, like a human society, depends on its size, I've found. So the amount of information flowing through the colony, the communications, the control of the environment around the colony. Self-reliance declines as colonies get bigger and more division of labor occurs. There can be teams and assembly lines that form in bigger societies. There's more infrastructure. Things like mass transit emerge in large ant societies. And even features of the market economy come out in the larger ant societies. And one thing that's unique between humans and ants is a capacity for warfare, which emerges in the large societies of ants. So there's more risk-taking in general as societies get bigger. So I've gone around the world looking, in many cases, for these large societies with their large-scale processes, like we've just mentioned, but some of the really cool things happen in the small societies too. And one pattern that has been found in humans by Louise Betancourt at the Los Alamos labs, for example, but it's obvious to most people, is that humans, when societies get bigger, when cities get bigger, things seem to accelerate. And it turns out ants show the same patterns. So I've been around the world looking, in addition, for some very small societies of ants. And some of the smallest you have to find using a crack team of experts. So in this first picture, you see Lloyd Davis and David Donoso in Ecuador, looking for the more obscure ants. And this requires that they be very patient. And they actually stare into these containers full of soil from the rainforest floor for hours every day, looking for dots that move. And those are some of the rarest and most extraordinary ants. And one of the really cool species we found down there in Ecuador was Basoceras singularis. And those ants are extraordinarily slow. They move at, well, glacial speeds. And we found out through watching this species in their small societies, maybe a dozen individuals, that, well, it seemed appropriate. These ants actually chase snails in super slow-mo. And so here you see the snail is making a dramatic left-hand turn to try to escape the ant, which has covered itself in mud, by the way, perhaps to hide. And these are the characteristics of small societies. And humans, too, societies accelerate as groups get bigger. Why is that? Well, you have more to gain moving fast in a big city like New York. In the small town, you know who you're going to see at the coffee shop. You know the coordinates of your day and what's going to happen. In big cities, all kinds of crazy things can happen. You can see an art gallery. You can bump into an ant expert. Whatever it is, there's a lot to be gained with type A behavior. So that causes people to accelerate, is what's been discovered for humans. It seems to be the same with ants. The bigger societies, like this acrobat ant colony here in Africa, there are individuals flowing past each other all the time, and they actually are taking in information about what all the other ants are doing as they pass by. So an ant might discover that a lot of workers are out there collecting food, and maybe not enough are taking out the trash. And so it may decide what to do that day based on this information. The amount of information flowing through the colony really accelerates the bigger the society is, both for ants and humans.